4 transformations, is it not? It is very simple, no? There is no complexity. So, but what I have omitted translation. Translation is the one way, it is the most easiest transformation.
Add an offset to every.
If you just add, it will move, something you add with that and it will move. So, suppose you have a point here 5 and 3 and you add another matrix, suppose 2 and 3 2 and 3 matrix, you just add it. So, what you will get 7 and 6. So, it will come to somewhere here, it will go somewhere there 7 and 6. This is a tricky situation, you should concentrate on this, what I am telling. Addition easily translate any point anywhere, okay. But that I have not taught you beforehand. The reason being that I want that every point should be transformed by a matrix multiplication. I will not use two operations for same transformation. When I will talk about transformation, I should see one matrix and one matrix operation, that is matrix multiplication, that is all.
Otherwise, you could have split it up into multiplication and then addition.
Yes.
Then or addition and then multiplication.
Yes. So, I do not want to use two operations. So, that is why I have not covered translation. Another issue is that it is a great problem, but when analytical calculation we do and somebody if do not specifically tell this point, it is very difficult to understand what is the implication of particular one situation that I am covering now. What is that situation?
एनालिस्ट होते हैं वो लोग यही टेक्निक्स यूज करते हैं, इजी सॉफ्टवेयर यूज करते हैं.
You make a triangle like that. Try to make a triangle. Just input, physically you will see what will happen. Oh, sorry. Yes, I'll do. So, you scale it any apply any matrix A B C D with any value. Any value you just change. What you will get? You will get a triangle like that, is not it? Whatever values depending on your entries, this shape will go on changing, but one thing will remain here, one point will not change, it will be stationary there. Is it happening?
Yeah.
It is happening.
So, suppose I look at rotation, then the rotation is going to be about that particular point.
No, what is the implication is that if your object contains a point which is at origin, whatever transformation you apply, it will not transform. So, suppose you have a object which was at center and one point will be at 0 0. Now, you have taken, suppose you have taken here and you have enlarged it. So, here all points will come here, but this origin will be there.
I mean, you are saying that point will not change.
that point will not come move with other points.
Right. The other that will remain fixed. Everything else will move.
Yes.
Right. So
Yes.
whatever is happening at about origin, okay, the point at the origin, everything is happening with respect to that guy. Everybody else is moving, but this fellow remains fixed.
No, it is not happening. This point is stationary. Suppose
Yeah, this point is fixed. All the other points of the object are changing.
so that object is getting distorted. No, I am suppose we six have connected with a triangle.
Okay.
And you are it is starting with my point, and you all are connected with one line, and this line ending coming to back to me.
Okay.
Now you all moves there. I will be here. So it is a distorted triangle then. So I cannot say that this whole triangle has been moved. This is a very vital point, and this is the issue, and in linear algebra classes these are being not deliberated, and this confusion remains with us.
Similar kind of distortion we were also seeing when we were doing it about plane rotation, right? When the object was not about a.
No, this is a unique case only if the object one point of the object is at origin, otherwise everything is normal. I will cite one example. Suppose you have a circle here, okay, circle here, and you have translated the circle. So what will happen? The circle will come move here, but one point, this point will remain here. So is it a total circle?
See, the distortion that we are talking about is still happening here, even when it is.
That is happening to all points, but one point is not changing. That you have to. I am distorting. Transformation means I am distorting all the points,
Right.
but all points should distort equally.
I see.
That point 0 is not distorting equally. It is distorting differently.
Scales are different. That is why it is actually.
We are
So it's dynamically changing the scale.
Yes. That's
When you rotate the
and
figure.
that is a software
no.
problem.
Just
Okay.
you think. See here, my triangle was there. This all the points constituting this circle.
That means unless we fix that problem, this interpretation is going to be difficult.
You see this graph, this triangle, all the points in this sorry, this is a circle, all the points are here, and I want that all this circle should move there. So I have moved all the points there, but 0 0 point, there was a point which was 0 0, it will not move, no. Whatever operation I do with 0 0, it will be 0 0 only. So here also this point will not move. So what will happen? This circle will have an extension like that. So this will be a distorted circle. One point is not there. This will be one incomplete point. Not yet clear? No.
We are not clear.
ये बोल रहा है ये this is
Okay. what you have only done is fixed the axis. ये देखो ये हो रहा है अच्छा ये not fixed the x axis.
Now you see this board.
आप थोड़ा आगे जाते तो हो जाएगा.
जनाब
Okay, na?
समझ में तो आ गया.
हाँ. You see this what is happening, this 2 3 is a point, and I have multiplied this by this matrix, and we have got this sorry, this point we have got, and this was our original point. Now, suppose this point is 0 0 0 0. So, that I am telling, in spite of I want to transform, this point is not getting transformed. So,
Point at origin remains at the origin. That's what you are saying.
So, if my object is there constitute a point at origin, it will never move or never distort. I cannot do anything about it. It will be stationary always. Whatever.
It will never move. It will distort.
No, it will. So how you can distort?
Distort meaning if the other points are moving, then since this guy doesn't move, with respect to the
object
original
will get distort.
Object will get distort.
But this point will be same point, no?
Yeah.
0 0 0 0 0 0. All whatever you go on doing, it will be always 0 0. That is not desirable. No, I want that all the points constituting that object should move, and it is not moving. So, what to do? That what to do, this has opened up a new world of geometry. This is very advanced geometry, and that I told if you know the requirement, if you go directly read something and without knowing that origin, then you will not realize what is the pain on that. Here is the pain that my object is not getting transformed. So, one of our great mathematician, he has contributed, his name is Phovius, I think. So, two issues with transformation. What is that? Origin remains stationary, it will not change, and
the origin remains stationary.
Whatever it is.
Because you know earlier yesterday we had said that points don't move at all. The objects that lies at that point.
So, that I am telling all these points you should constitute as a vector on that, and it is a 0 vector. So, 0 vector will not move.
So, your position vector of the origin does not change. Is that what you are saying?
So, the two issues has come, origin remains stationary and translation cannot be achieved through with matrix multiplication. I want to do that.
By the 2 by 2 matrix multiplication. Is that what you are saying, that translation cannot be achieved by the 2 by 2 matrix multiplication?
Yeah. Okay.
That's what it is.
So, Mobius, I think 1857, he has introduced a special coordinate system, that is called homogeneous coordinate system. Homogeneous coordinate system, and I will be talking about that. I will give some introduction, but I will be doing practice after break. Okay. What is this homogeneous coordinate? Apparently, it is very easy, but the thought behind that and that analytical process, how he has achieved this, it is a very complex. We will not go into that depth, but it is one thing we should try to understand what he was trying to do. This is a thing, you just think of a situation when something goes away from us, no, it appears smaller and